Hello friends, welcome to the class on control engineering. So in this video we are going to solve another problem on root locus. So the open loop transfer function is been given like this. For this open loop transfer function we have to find out the root locus. So solution, what is step number 1? To get the general information, that is number of poles. So here the number of poles as the denominator term, so is p is equal to 3. Why 3? So highest order is s to the power of 3. That means s we have, then s square we have. That means there are 3 terms are there. So therefore p is equal to 3. Then number of zeros, that is the numerator term, that is equal to 0. Therefore number of branches is equal to how much? That is equal to 3. So therefore what is the starting point of the branches? That means the roots of the denominator, that is poles. So that we have 0 and we have a complex pole. How to identify the roots? So we are going to use a formula that is equal to minus b plus or minus root of p square minus 4ac divided by 2a. So we are going to use this formula to find out the roots of this complex pole. So if I apply this formula, I got minus 3 plus I and minus 3 minus I. Okay, so this is the starting point of the branches. Next, ending point. The branches are going to end at zeros. So here we don't have any zeros. Therefore, all the branches are going to end at infinity, infinity, and infinity. Okay. So step number 2, to plot pole 0 plot. So for that we are going to draw a pole 0 plot. So predicting the root locus on the real axis, that we have s is equal to 0 and the another one is minus 3 plus I, then another one is minus 3 minus I. Okay, so how many roots are there on the real axis? We have one root. So we are not going to consider this complex poles. Okay, we are going to find out the roots on the real axis. So if I draw the imaginary axis, so root locus is possible on anywhere, breakaway point, that is root locus is possible anywhere on this x-axis. That is the prediction. So next one is step number 3, to find out the asymptotes. So therefore number of asymptotes is equal to p minus z. So how much is this? That is equal to 3. So therefore what is the formula? Theta is equal to 2q plus 1 into 180 divided by p minus z. Your q is going to vary from 0, 1 and 2. Why? Because the number of asymptotes is equal to 3. So therefore theta 1, that is when theta 0, when q is equal to 0, what is this? That is 60 degree. When theta is equal to 1, that is theta 1, q is equal to 1, that is 180 degree. I am going to substitute here. Then I am going to find it, right? Theta 2, that is q is equal to 2, that is equal to 300 degree. So this is the step number 3. Next to step number 4, to find out the centroid. Centroid is equal to summation of real part of poles minus summation of real part of zeros divided by p minus z. So here what are summation of real part of poles? See here. So we have 0, real part only, minus 3, minus 3, minus summation of real part of zeros, we don't have any zeros, 0, p minus z, that is equal to 3. So we have minus 6 by 3, it is equal to minus 2. So this is the centroid. Next one is step number 5, to calculate the breakaway points, right? To calculate breakaway points. So for that we need a characteristic equation. What is the characteristic equation? 1 plus g of s h of s is equal to 0. So here you need to make sure that sometimes they will be giving a negative feedback control system. So if it is a negative feedback control system, then this will be positive. If they give positive feedback system, then the characteristic equation will be 1 minus. Okay, if they are not going to give anything, then it will be a plus. We are going to assume it as a negative feedback. Okay, so next one, what is 1 plus g of s? What is g of s into h of s? That is k divided by s square plus 6s plus 10 is equal to 0. So then if I simplify this, the k value, that is equal to minus of s cube plus 6s square plus 10s. Okay, so this is after simplification. So next one, so what we have to do, so this one I'm going to equate it as equation number 1. So I'm going to differentiate this k with respect to s. So then I will arrive at 3s square plus 12s plus 10 is equal to 0. Nu I am equating to 0, this minus will be gone. Okay, so with the help of calci I am going to solve this to find out the roots of this s. So after using the calci, I found out that s is equal to minus 1.18 and also s is equal to minus 2.8. Okay, so I am going to substitute these values in the equation number 1 to find out the values of k. So here the k will be equal to 5.088. That means I am going to substitute this value in the equation number 1 and find out the value of k. When s is equal to minus 2.82, the value of k is equal to 2.911. Okay, so these are the values of k when s is equal to so on. So that means both are positive, right? So we got both are valid breakaway points. Okay, next let us go to the step number 6. What is step number 6? Wait a second. Okay, after finding out the breakaway points, the step number 6, that is intersection of root locus with imaginary axis. Intersection of root locus. So for that I need to have a characteristic equation. We found out from the previous step the characteristic equation is equal to s cube plus 6s square plus 10s plus k is equal to 0. So with the help of RH method I am going to form the arrays s to the power of 3, s to the power of 2, s to the power of 1 and s to the power of 0. So what is the coefficient of s to the power of 3? It is 1. I am going to leave another term, that is a 10. Then this row will be 6 and k. I hope you know this RH method. So I am going to find out the next array with the help of these two rows. 6 into 10, that is 60, minus k into 1, that is k, divided by the first element of the previous row, that is 6, and this will be 0. And the same way using these two rows I am going to find this into this minus this into this divided by this. I am going to arrive at k. Okay, so to find out so for this to be stable, so this value must be positive and this value must be positive. So therefore the k must be greater than 0 because here we have k. Okay, so to find out this value I am going to consider 60 minus k divided by 6. This must be greater than 0. So after equating to 0 I found out k will be equal to 60. Okay, So k will be 60. This is a k margin. Okay. So next we need to consider the auxiliary equation. That is auxiliary equation. That is a s to the power of 2. So we have s to the power of 2. That is, I am going to form the equation from this row. That is 6s square plus k. That is equal to 0. So what is the meaning of 6s square? Is equal to minus 60. Why? I am substituting the k is equal to 60 that I found out in the previous step. So s square is equal to minus 60 divided by 6, that is equal to minus 10. So s is equal to plus or minus root of minus 10. This is equal to plus or minus I 3.162. So this is the intersection of root locus with the imaginary axis. So next, what is the step number 7? So here we have a complex pole. So therefore we will be having an angle of departure, okay, at complex poles. To calculate angle of departure, right? So this is a step number 7. So what is the formula we have? Summation of the angle of departure is equal to 180 minus of summation of poles minus summation of zeros. Okay, how to find out summation of poles and summation of zeros? That is a very much important now. So I will explain you over here. For this, what I am going to do is I am going to draw a pole 0 plot like this. Okay, so what are the roots we have? We have poles, we don't have any zeros, that is pole. What are the roots? S is equal to 0, right? What are the roots? S is equal to 0, and another one is minus 3 plus I and minus 3 minus I. So now I need to find out the angle of departure for minus 3 plus I and minus 3 minus I. Okay, so let us find out the angle of departure for this, that is the minus 3 plus I. So apart from this, what are the other poles we have? So we have this s is equal to 0 is also a pole, another pole is minus 3 minus I is also another pole. What I am going to do, I am going to draw the line from this to here. Okay, so I need to find out this angle. So this is a summation of phi p1. So this is a phi p1. So what is this? So minus 3 plus I, that is, so it is a complex x plus iy, right? What is x? That is minus 3 from year to year, so it is 3. Okay, from year to year it is 1. So I can easily find out this angle. How I am going to find out? With the help of tan inverse of y by x. If I apply this, I am going to find out the this angle, that is this. So but I need phi p1. Okay, so what to do for that? So let us show you. So summation of phi, that is summation of phi poles, is equal to, so apart from this pole I have two other poles. This is our first pole and this is another pole. I am going to draw a line from here to here. So what is the angle from this to this? So this is a phi p2. Okay, so I need to find out phi p1 and phi p2. So summation of poles is equal to phi p1 and phi p2. So I am going to find out this angle by applying this tan inverse of y by x. Okay, So summation of phi p1 plus phi p2, whereas phi p1 is equal to 180 minus this angle. So that I can angle found out by tan inverse of y by x. So therefore it will be 180 minus tan inverse. What is y? That is equal to 1. What is x? That is equal to 3. So 180 minus this angle. So that I am going to get as, after simplification, 161.56. Okay, so this is after simplification. Okay, so therefore this angle is equal to 161.56. Okay, so next, what is phi p2? What is phi p2? So this is exactly below this. So the angle made by this with the reference line, that is the horizontal line, that is x-axis, that will be equal to 90 degree. Therefore summation of poles will be equal to, that is phi p1 plus phi p2. So that I am going to arrive at I am going to substitute these values in this angle, in this formula. Okay, summation of poles, angle of departure is equal to 180 minus 161.56 plus 90 minus summation of zeros. So in this problem we don't have any zeros, so therefore this will be equal to 0 only. So therefore I am going to arrive at minus 71.56 degree. So this is the angle of departure for what? S is equal to minus 3 plus I. So in the same way I need to find out the angle of departure for minus 3 minus I. So these are the two conjugates. So therefore, so phi dash, that is another, the angle of departure will be equal to minus of phi d. So this will be plus 71.56. So for phi d it is minus 71.56. Phi dash, that is the angle of departure for the another pole, that is equal to plus 71.56. So this is how I am going to find out the angle of departure. So what is the next step? So we have to combine this step number 1 to 7, and we need to write down the root locus. Okay, so let us start doing that. So first I am going to draw the S plane. Okay, so here I am taking the scale as 1.5 for one root, one unit. So this will be 0 plus I plus 2I plus 3I. This will be minus I minus 2I minus 3I. So this will be minus 1 minus 2 minus 3 minus 4. Okay, so what are the roots that we have in this problem? So the first thing we have to do is number of roots. So S is equal to 0. Okay, then S is equal to minus 3 plus I, minus 3 plus I. So this is a minus 3 plus I, so approximately here. Okay, minus 3 minus I, approximately here. Okay, what next? So we need to find out the we need to draw the asymptotes. We have 3 asymptotes are there from the centroid. What is the centroid? We found out minus 2. So this is the centroid. How much is this? Minus 2 is the centroid. from the centroid I am going to draw the angles. What are the angles they are told? The first one is theta 0, that is equal to how much? 60 degree. So with the help of protractor I am going to mark 60. And the next one is so let me draw this. So this is the theta 0, that is equal to 60 degree. Then theta 1, that is equal to 180 degree. Then theta 2, how much is this? So this is equal to 300 degree. So you can mark it over here. Okay, so 300 degree. Okay, so this is a theta 2, that is equal to 300 degree. So this is how I am going to mark the asymptotes. Okay, what is the next thing? So we need to find out the breakaway point. So we have two valid breakaway points, that is minus 1.18 and another one is minus 2.82. Okay, so what is the breakaway points? Let me mark. That is minus 1.18. So this is 1 approximately here. Okay, so this is the breakaway, first breakaway. How much is this? Minus 1.18. Okay, and another breakaway that we got is minus 2.82. 1 2 minus 2.82 approximately here, that is breakaway. How much is this? Minus 2.82. So these are the two valid breakaway points. Okay, so what is the next thing we have to find out? We have to enter is intersection of root locus with imaginary axis. It is plus 3.162. So this is 1 2 3 3.162 3.162 approximately somewhere here, 3.162. so this is intersection of root locus with the imaginary axis, 3.162. in the same way I need to find out here. So minus 3.162. This is the intersection of root locus with the imaginary axis. Okay, so what next? So we need to draw the angle of departure and angle of departure, right? So angle of departure is minus 71.56. How to draw this? So from this is a reference line, right? This is a reference line. This is a reference line. Angle of departure, so for this is minus 71. So I am going to hold the protractor like this. So here it is 50 60 70 71 approximately somewhere here I am going to get. So I am going to draw a line, just a small line. Okay, how much is this? This angle is equal to minus 71.56. Okay, so next, what is the angle of departure? For this it will be plus 71.56. so I am going to draw like it is upwards, right? Plus 71.56 somewhere here. Okay, so I am going to draw the line above line. So how much is this? It is 71.56. so this is how I am going to draw this. Okay, as we know, all this are going to end at infinity because we don't have any zeros, all these are going to end at infinity. So next thing is to draw the plot. Okay, so at this value, what is the value of k when s is equal to minus 1.18? The k value will be equal to something 5.08, right? So this k is equal to 5.088, and at this point the k value is equal to 2.911. Okay, so as we know, so the branches are going to start from the poles and it is going to end to the zeros. So here we have one breakaway point minus 1.18. So here in between that we have two poles are there. So one of the branch is going to start from here. Okay, so one of the branch is going to start from here and it will come to the breakaway point. So from 0, so we have 0, right? That's the first rule. It will approach to the breakaway point. Here it is going to break and here it is going to break. Okay, in the meantime, other two branches is going to start from this and it will approach towards the breakaway point like this and like this. Okay, it is going to approach to here. We have two breakaway points and it will come to this breakaway point. Okay, so one of the branch is going to come this side, another branch is going to move in this direction because we have one more asymptote, that is theta 2 is equal to 180 degrees there. So these two branches from these two poles, it will arrive at breakaway point. From this breakaway, one of the branch is going to end at infinity following theta 1 is equal to 180 degree, and another branch is going to come at the another breakaway point. So at this point it is going to break and it is going to move towards the intersection of root locus, that is 3.162 and minus 3.162. At this value k is equal to how much? We found out k margin. What is the k margin? So 60 degree. So k margin is equal to 60. Okay, at the intersection. So k is equal to 60 and here also k is equal to 60. After this it is going to follow the asymptote, that is theta 0 is equal to 60 and the other value theta 2 is equal to 300 degree, like this. So this is how we are going to draw the root locus. Okay, so after drawing the root locus, the final step is we need to give the comment on the stability. Okay, what is the comment on the stability? So you have to pay attention when we are going to vary the value of k from 0. So the roots are to the left side of the s-plane until when k is equal to 0. So therefore, so k must be greater than 0 and less than 60. So in this region, so this will be stable. So after at k is equal to 60, it is marginally stable. When k becomes greater than 0, the root locus is moving towards the right side of the s-plane. This is the unstable region. So this is what the comment on the stability. I hope you understood. Thank you. Namaste.